All right. Okay, let's get started. So today we're going to talk about one of my favorite topics, the debugger. But before we get into that, I want to just talk about logistics a little bit. I haven't been talking about like homework logistics very much, so let's just talk about a little bit of it. I don't want to take too much time with it. But the deadlines for this week were pushed from Wednesday to Friday. That included all deadlines. So, of course, the two that you see here, as you're well aware of, that happened this morning. But also the recovery opportunities were pushed back. If you used a recovery opportunity on task 1, that was pushed to Friday as well. So I just moved every deadline. Anything that was supposed to be due on Wednesday was instead due Friday. And with the warning, I guess, when the deadlines did move, I warned that the following week's deadlines won't move. So just a reminder that we do have a bit of a short week if you did wait to the last minute and did actually wait all the way till Friday this morning to finish up whatever was due this week for you, that you effectively have a 5-day week to get the next deadlines met, which does include recovery opportunities. So if you needed a recovery opportunity on task 2, you basically got the first 2 days for free, and then the recovery opportunity takes you to Wednesday, so it's a 5-day extension. So I want to make sure everyone's aware of that we're going back to Wednesday deadlines next week. We only had that little extension because we had that crazy ice storm, which was pretty wild as well. I don't remember ever seeing something like that. I've been in Buffalo my whole life. It was a wild storm. But, and I definitely don't want to spend too much time on this one because most of the people who need to hear this probably aren't in lecture or not paying attention. So, but if you need recovery opportunities are always automatic. So when you miss an expected deadline, when you miss an actual deadline, I go in, I've been good about it this semester, try to get them done right after the deadlines. But if you miss a deadline within an hour or two so far, I go into AutoLab, mark your extension, give you an extension, so AutoLab's accepting your submissions again. And then I update your number of recovery opportunities used in AutoLab so you can see that you've used a recovery opportunity. You can see it officially. It is manually processed, but it will be there if you miss a deadline. If you miss one of those deadlines, Paul and I assume that you'll use the recovery opportunity because your alternative is just failing the class. So of course you're going to use it, so it's automatic. You don't have to let us know that you're going to use one. And same for the labs. If you need to take the recovery opportunity lab, the usage is automatic. If you fail the first 2 times, either the interview or the quiz, or both, the usage of a recovery opportunity is automatic. You just show up to this lab and take your interview or quiz, and you can check in AutoLab. That one's going to be a little tougher because grading is on a rolling basis for labs. But eventually you'll see before your lab that you've used a recovery opportunity for that. If you need to use a recovery opportunity for both the quiz and interview, if you failed both of them both times, it is 2 recovery opportunities that you have to use. You don't use an RO just for the lab, the whole lab itself. It's for each of them. But again, that's automatic until you use 4 of them. Once you need your 5th one this early in the semester, there's not much leniency. If you need a 5th one this early, it's game over in most cases. In the second half of this semester, as I mentioned on day 1, the second half of this semester, you survived quite a while and you're just struggling with a few things. I'm usually more generous of giving a 5th one, but some people have already used 3 recovery opportunities this semester, which I assume they're not in the room right now. Most of them haven't made a single submission to anything ever, haven't showed up to labs and haven't submitted any homework assignments, but there's dozens of them, dozens of students who just are not participating in the class. They're not going to get much sympathy. Probably because, actually they probably would if they showed up and said, hey, I had stuff going on in my life or whatever. But they probably won't show up. Historically speaking, they won't. So anyway, I don't want to dwell on that stuff. On the more positive side, the expected deadlines are also updated in AutoLab. You can go to your stats section, expected deadlines met, and see how many of those you've met. A lot of you did meet both of them. So on the other side of things, a lot of you are doing really good and both of them, all three of them. Half of the class across all sections has met all three expected deadlines. I believe that's a true stat. So we have those as well. And for the lab next week, we have Data Structures 1 second chance and Classes 1 third chance. If you need to show up to, I already covered that, but Classes 1, if you need the RO, you can show up and take the quiz and interview. Just a reminder, though, that you can't get the application objective on the quiz if you're using a recovery opportunity for it. You can get the application objective on the first 2 attempts. Those are the free attempts. Everybody gets those, no questions. But you can't use a recovery opportunity to get a third, fourth, fifth, etc. chance and earn the AO on any of those chances. So if you didn't get the AO for Classes 1 this week or last week, your next chance is all the way down here on the final exam. You can show up to the final exam and get your third chance to get that AO, which I think is probably a little too generous that you get 3 chances for that AO. But it is what it is. It's a little bit thing we're trying out this semester. Maybe we'll get rid of that in next semester and go back to not giving you 3 chances on that. But you get 3 chances this semester. Take advantage of it while you can. But you can't get the application objective on Classes 1. So there's no new lab next week. There's no lab, interview, or quiz related to testing weeks, this week being a testing week. So if you've completed everything that's available for you on this week of lab, there's no reason for you to go to lab next week. So if you've already gotten the Data Structures 1 interview and the quiz, both the learning objective and application objective on the quiz, and the Classes 1 quiz learning objective, you can't get the application objective next week, and the interview learning objective. If you've completed all 5 of those things, don't show up to lab next week. We got nothing for you. There's no reason for you to be there. And this is by design. Paul and I designed the class such that if you're keeping up on everything, you're nailing these quizzes and interviews in the first try every single time, and you're just keeping up with everything, studying, showing up to class, paying attention, all that good stuff. Every third week of lab, you should get the day off. You don't do anything. You don't show up to that lab. That's our I guess reward. I don't know what to call it. But that's your benefit for being up to speed on everything. You just don't show up every third lab. So next week is the first time where that comes up, where if you nailed the first chance on everything, don't show up to lab next week. Do whatever the hell you want during those 2 hours. If you do need to make up something, of course, show up and make up your stuff. But next week's lab is really the same structure as this week's lab. You're doing the same things are available, except you can't get the AO on Classes 1 quiz. So, any questions on all of that, all the logistics? Tried to keep it compact a little bit here. How long does it take for our labs to get graded? Generally 5 to 6 days. They got to get your grades out before your next lab, because you need to know if you have to take the makeups, the next chance or not. I'm not sure exactly where they're at with grading right now, but you'll always get grades before your next lab. If that's ever not true, make sure you raise hell, because that's something we got to fix. I got to yell at some TAs about that if they miss that deadline. Oh, and there's apparently I didn't check the Piazza post for when grades drop. What happens if you miss the second chance by accident? Accidents are on you. If you have a valid excuse, it's one thing. We can talk about it. But if it's an accident, you just miss it. Would I have to use an RO? Yeah. Yeah, if you just sleep in and miss lab. And that's why you get 2 chances for free. I understand that things happen. Anything can happen to make you miss a lab. That's why you get 2 chances. If something happens to you 2 weeks in a row, now I'm getting suspicious. Okay, something's up with this student. But 1 week, things happen. Just go to the next one. Go to the other one. But if you both failed the first one and then something happens on the second one, that's still on you. You didn't pass the first time. But that's the reason we give 2 chances, so life can happen and it doesn't affect you. And that's why we get the ROs as well. Even with you fail the first one, you miss the second one by accident, you just use an RO or 2 if you need the quiz and interview and show up to the recovery opportunity chance, and you still get back on track in the course. The only thing that can really, you get so many extra opportunities in this course, the only thing that can really set you off track is if you don't study and you don't know what's going on. That's the only thing that can really knock you off and get you to fail this course. Which unfortunately the material is pretty hard, so that is fairly common. But I want to make sure that the whole structure of the course is generous enough that you're not just going to get screwed out of a good grade. Can you use a recovery opportunity to push back the test deadline for an AO? No. You can't use any recovery opportunities for anything related to AOs. And the reason for that is if you use one for an AO and then you also need to use one for an LO later, but you used your last one on an AO, now you're failing the course because you used a recovery opportunity on an AO when you need it for an LO later. So I don't let any of you get in that situation where you're making a decision, where you're basically gambling an RO to try to improve your grade and end up failing the course. I don't want anybody doing that. So just no ROs on AOs at all. I got to parcel this. If we got the AO and LO for the data structures but fail the interview, do we need to give both the quiz and the interview on the second chance, or only the interview will do? Only the interview. If you pass the lab and the quiz and interview are two completely separate things. If you pass the interview, you're done with the interview. If you pass the quiz, you're done with the quiz. And if you fail both of them twice, then you need to spend 2 recovery opportunities to retake both of them. They're 2 completely separate entities. They just happen to be co-located time-wise because lab's the convenient place for us to do both of those. Okay. Let's talk about this stuff. So let's get into some debugging. I want to cap the logistics talk for a while. Plus, some of these questions are just answered in the syllabus. Let's talk about task 1. Everyone's done with task 1 by now, either literally done with it, or the students who don't have credit for task 1, I like to be optimistic, but they're probably just done with the course. There's not much else to say. A lot of the students who don't have credit for task 1 didn't even make a submission yet. They're just not participating. So I can comfortably give solutions, at least partial solutions, that I'm going to do now for task 1 without really affecting anybody. So let's talk about sum of digits. I have my sum of digits solution here. I have my parameter n, and I have this habit where whenever I'm going to modify a parameter, I'm going to store it in a separate variable, and then I'm going to modify x. So when we reassign x, I'm going to have it stored in a separate variable. Java actually lets you change the values of parameters, but a lot of languages don't, and Scala didn't. So I got in this habit of reassigning it to a separate variable that I'm going to modify. So anyway, I'm going to store the parameter value in x. I'm going to initialize my answer to 0, and I'm going to loop through x. And each time I loop, I'm going to get the ones digit and add that to my answer. And I'm going to divide x by 10 to slide all the digits down by 1, basically erase the ones digit from this value. And then once I'm done looping through x, I'm going to return the answer, which should be the sum of digits. This is my expected solution. Some of you had different approaches, different solutions. I like seeing the creative solutions. In last lecture, somebody said they converted the int to a string and iterated over the digits and summed them up. Perfectly fine. I like that solution. It's creative. This is the intended one. This is why we showed you those examples in lecture where we used the modulo to get the ones digit and we used integer division to get the tens digit. That was all designed to help get you started on this. If you pay attention to those grade examples, the plus, minus, and the letter grades examples in lecture, it was strictly designed to help you get sum of digits here. So when somebody in office hours asked how to get the ones digit and modulo operator, or they didn't know what modulo operator was, it was pretty clear they just didn't pay attention in lecture, which it is what it is. But that's where we were directly given hints of how to do this one. And this is about what we expected. And then for tests, I have my test case set up, test suite set up. I could use more tests here. I probably should have just added more before this lecture. But I have my tests here. where I'm using a hash map like we saw on Wednesday. I'm adding my test cases, my inputs and expected outputs into this map, iterating over the map, and then calling sum of digits for each, and then asserting if I got what I expect. And I'm going to run this. Test, yeah, I got the right one. Timing, come on, Java. And I get this. Some of you have seen this. I saw this a bit in office hours. This is a pretty common problem with sum of digits. You just get this. Now we got our hint text in the assert, so when our test fails, we get some clue as to what happened. We could add print lines throughout here to, good old-fashioned print line debugging, and get information about what happened. And then when we run our test, we get this and zero information. We get nothing. What do we even do with this? What the hell do we do? So let's use the debugger. So today is all about the debugger. And let's use this when we don't really have much information to go off of, or all the time. We're going to use the debugger to learn about our program and how it's running. And I'll maintain, I say this all the time, I think this is absolutely true. If there are two things that you can do, if you're doing both of these things in this class, you should never need office hours, you should never need Piazza, you should never have to ask a TA for help, except for like the really obscure, maybe you ran into something really crazy and you just need somebody to help explain it to you, or you're struggling to understand the concepts overall, and you come to office hours so we can help you with the concepts. But you should never need help with just straight up coding something. Two things. One, testing. We've been talking about that forever. I don't have to dwell on that. Sit down to write a really good test suite with lots of test cases, a good variety of test cases, all those things that we talked about. Think about the edge cases, and just write really good tests, really good thorough tests. That's the first step. Not just writing the bare minimum tests. Sometimes the way that the incorrect solutions in Autolab just happen to line up, you might just find that one or two test cases that satisfy Autolab, and then you're like, oh, I'm done with testing. Autolab's happy, I'm happy. That's common in this class, and I'll see students in office hours with like literally one test case, and I'm like, where's all your testing? They're like, Autolab liked it. Autolab said it's good, whatever. And it's like, God damn it, it hit all my incorrect solutions all in line with just that one test case. That doesn't mean you have good testing just because Autolab says you're good. It just means you had enough to knock out those incorrect solutions. So if you sit down and just really write a really good test suite, thinking of all the different cases to throw at it, then that's the first thing. This is a pretty good test suite. Like, I could use more test cases, but I have all the core things that I need. I have a large positive value, a large negative value, a kind of typical test case, and a couple edge cases, especially zero. I got a good variety of test cases. I could use more test cases in each of these categories just to really be sure, but I have like each of the categories of test case that I really need to test for this thing. So good test suite, and then two, the debugger, the thing we want to talk about the rest of the lecture. So if you write good test cases, and then you start writing your code using test-driven development, get all your test cases first, and then start writing your code, when you write your code, it might be hard to get those test cases to pass because they're testing everything. And when those test cases fail, you run the debugger, figure out what happened in your code to make it fail, and then fix that bug. Find your bugs one at a time with the debugger. It's called the debugger for a reason. It helps you get rid of your bugs. If you do those two things, I don't think you'll need office hours at all. It's very rare to have a student in office hours with a really good test suite with the debugger open and saying, I just don't know what any of this means. It happens, and I'm very happy to help those students, by the way, because they're clearly doing the things that can help them succeed. But doing those two things, you won't need office hours, Piazza, TAs, me, Paul. You might barely need lecture if you're doing those. If you get in those two habits, and that's something that's not just within this course, but your whole career. The debugger is something that can save you countless hours, can prevent sleepless nights. It's something so valuable that it's just an extremely useful skill to have. I know that because I went way too long without the debugger. Embarrassingly, I didn't know about debuggers until I was in grad school. No classes covered it. We covered it in several classes now, starting with 116. But I didn't know what it was, and when I finally found out, I'm like, where the hell has this been all my life? This is the best thing ever. Saved me tons and tons of time. All right, so enough of that. Let's get into this. I very briefly showed the debugger last Friday. Let's see it again and in full action. So to run the debugger, first I'm going to set what's called a breakpoint. And then instead of running my program, I'm going to run it in the debugger. I'm going to use the debug button. What this does is runs my program until it reaches a breakpoint. Once it reaches a line with a breakpoint, it will stop, importantly, before the line is executed. So this is the line that's about to be executed. And it'll stop everything and show us the state of memory. It shows us all of the stack frames and all of the variables inside this stack frame, including references to values on the heap. And you can open up the drop-down value to see what's on the heap at that value, at that object. Now, we do have this. This is a non-static method, so we technically have this, but we wouldn't be concerned about that in our memory diagram. This is an object of type test problem set, which is this class. We had to instantiate this class to be able to get a test sum of digits method, so this has to be in here. The keyword this does have to be in there, but for this example, we wouldn't be concerned about it. So sometimes the debugger gives you some extra information, but otherwise it's giving you the same information that you see that you would put in your memory diagrams. So whenever I get the question, how do I test memory diagrams? How do I know my memory diagram's correct that I'm using for practice? My answer from this point forward is going to be run the debugger, because you'll know how to use the debugger after this one. And we can see that there's a lot of stack frames on the stack here. I told you JUnit and IntelliJ, there's a bunch of overhead, and that's how it runs a lot of stuff before it actually runs your test case, your test methods. And every Java program does start with a main. We can see if we scroll all the way down, there was a main method called from the JUnit library that actually started the program, and then that eventually called your test method. But there's a whole bunch of overhead, a lot of stack frames. Again, we're not concerned about any of that. Any stack frame highlighted in orange like this, that's internal to Java or a library. It's not code that we wrote, so we're not concerned about it. We're not going to debug Java itself. We're going to trust that Java has already been debugged, that everything is working as it should. So let's close all those. And now there's, I think, 6 total buttons that I want to show you to use on this console. Very first one, the one we've seen before, the step into. This is going to execute the next line of code. So we have the highlighted line. That's where we're at right now. And step into is going to run that line. So I click this a few times, and I can see my test cases map. I can expand this to see this is the variable which just stores a reference to a hash map on the heap. If I click the drop-down, it's going to show me all of the values in that object on the heap. So clicking one of these arrows is following the reference, and I can see I have 0 mapping to 0, 1 mapping to 1, 586 mapping to 19. And since this is a hash map, the order is not preserved. This is not a sequential data structure. So I can see that my test cases are kind of shuffled in a different order than the order in which we inserted them. They're also going to be iterated over in a different order than we inserted them. That's perfectly fine. That's normal expected behavior, and some we deal with key value pairs. Not general key value pairs, but when we're using a hash map like this. And let's keep going through. So we can see that the input of 0 is the first input that we run into. And I'm going to keep clicking step into. We're just focused on step into at the moment. And now the next line, this line that's going to be executed, is going to create a stack frame. So the next line that's executed after that is going to be inside our sum of digits method. We're going to get x equals n, answer equals 0. We can see our variables being put on the stack. We have the parameter n and local variables x and answer, all on the stack inside this stack frame. We can also jump back to our other stack frame. We can see all the values that are on the stack in this stack frame to see our entire stack. But again, stack frames are completely independent sections of the stack. They're completely independent. The variables in this stack frame completely separated from the variables in this stack frame. And we're going to hit our loop. Well, x greater than equals 0, we're going to execute this loop. 0 is greater than or equal to 0. So we're going to start running our logic. We're going to get the ones digit and add that to our answer. That's 0. And then we're going to shift everything to the left by erasing the ones digit in x, or to the right, not to the left. And we're going to hit our loop again. X is still 0. 0 greater than or equal to 0 is true. Take the ones digit, divide by 10. 0 is still greater than or equal to 0. Still greater than or equal to 0. And we've gone infinite. So we've hit an infinite loop here, and that's what happens when you're testing and you see just the loading icon. That almost always means you've gone infinite in one way or another. Either an infinite loop like this or infinite recursion. You're just constantly calling the same method over and over. So this method never returns. Since it never returns, we never got to an assert never failed, and the test never passes, your code is just running forever. And that's what you'll see when you go infinite. You'll just see the loading icon on your test. So testing, our hint text, everything we've seen so far wouldn't help us with that. You can either stare at your code and just try to figure it out, or run the debugger and see what's going on. I ran the debugger. I can clearly see at this point that I'm going infinite in this loop, and I need to fix it. So I want this loop to break when I reach 0. If I'm constantly dividing by 10, and this is integer division, so this number is always decreasing, I want to stop when x is 0. So I want to change my conditional to say, hey, if x is 0, I really want this to break out of this loop. So x greater than 0, strictly greater than, that's going to do it for me. Now, if I keep stepping through my debugger, the debugger won't see that change in code. It won't recompile it. It won't see that change at all. So the second button we want to see, I'm going to do this rerun button, probably the least interesting because you would have found this no matter what. I'm going to restart. That's going to run. Actually, I don't want to use that one. It does have to recompile, though. I'm actually going to stop it once it runs. And I have this breakpoint right here when I'm adding my test cases, but we've already looked at all this code. We've seen adding test cases to the map. We know there's no bugs there. We're adding key value pairs to a map. Like, there's not much going wrong there. We've seen this expected and returned, access, iterating over the key value pairs. That all looks good. So what I'm going to do is set a new breakpoint right next to the code that I updated. So once I reach this code, the code that I'm interested in testing and debugging, the code that I just changed, I'm going to set a breakpoint there and then restart my debugger. And now the debugger runs until it hits a breakpoint. So it's going to run until it hits that breakpoint for the test case. And I can jump right to the code that I'm concerned about. X equals 0, n equals 0. Well, x greater than 0. Return answer, which is 0. My expected and returned are both 0. I'm going to assert. We pass the assert. And we're ready to go on to the next input. Next input is 1 and 1, and I expect 1. So now the next button I want to show, first I'm going to go into problem set and remove my breakpoint because I forgot to do that last lecture. But the next button I want to show is step over. Step over. This means run the next line of code entirely. Even if that next line of code is going to create a new stack frame, don't show me anything about that stack frame. Just skip over it. Just skip that whole stack frame. So sum of digits with an input of 1, I'm pretty confident that's going to work, and I want to get to a more interesting test case. So let's just skip over the whole thing. We see that it returned 1. We're going to assert that 1 equals 1 and move on to the next test case. Now, the next test case is a bit more complicated, so I want to step into again and see if it's going to work on a more complicated test case to see if it's actually doing what I want it to do, if this method is doing what it should do. So, this large number is greater than 0. I'm going to take the ones digit and add it to answer. And then I'm going to erase the ones digit. So we can see x gets rid of that 0. It's still greater than 0. So we're going to add the ones digit to answer and then erase the ones digit. Add 8 to answer, erase 8. Add 7, erase 7. It's looking like it's doing what I want it to do. Let's make sure that it breaks when I want it to break. When I say break, I mean break out of the loop, not like break, like the code is broken. Make sure it exits the loop. So on the last iteration, 1, I should be adding that. And then 1 divided by 10, take the remainder, is going to be, not the remainder. 1 divided by 10, integer division, is going to be 0. 0 greater than 0 is false. We exit the loop, we return what we expected, and we're feeling good. And now at this point, I pass the test case like that. Usually what I'm going to do is shut down the debugger and say, I'm good with this code. Let me make sure, and just shut down the debugger so I'm not clicking line by line for all my test cases or using step over or whatever. I'm just going to run the whole test suite and expect it to pass, and oh crap, it failed. So I'm moving on to testing the whole thing, and it did fail, so I want to use the debugger again here to figure out why it just failed. So 0 did not equal 45. This assert failed, and I don't have a great hint text here, so I have to do a little bit more looking around to see what happened here. So 0 did not equal 45 is the hint text that I gave myself, and I kind of course, purposely put myself in a position where I need a debugger to get some more information. First, I'm going to deduce a little bit. There's 2 test cases that expect 45. This one we just stepped through in its entirety, and it wasn't that one. That one passes. So I'm eyeing this test case right here. This is the test case that I'm suspecting is the issue. So now I want to run the debugger again with that test case. So let me set a breakpoint right here again. I'm going to break right when I get the input out of this hash map. And we're going to get 0, 1, that long number and stuff. And this is where I want to show the next button. We got 2 more that I want to show. The resume button. So the debugger runs until it hits a breakpoint, and then you can step through, step over, step out is the last one we're going to see. You can also resume the program. What this does is picks up execution again until you hit another breakpoint. So I'm going to resume. Now I'm at input 1. Resume. We go through a whole test case, do the assert, get the next value out of the map. We get to this input, resume, and now we get to the input that we're concerned with. This is the one we expect to be failing. Now let's go into problem set, reset our other breakpoint, resume again. It's going to run until we get to this breakpoint on the test case that we're interested in. And now we can see what happens with this test case. So x is negative a bunch. We're going to check, well, x greater than 0. And oh crap, we didn't even go into our loop. Our loop was completely skipped. Now this is something that can take a while to spot if you're not using the debugger. You can stare at this code for a while and try to figure out what's wrong with it before eventually, and maybe a lot of you saw it right away, some of you it might take a while to look at. If you're in the middle of a programming session, you're sitting down to do task 1 and your brain's already half mush, it can take a while to say, oh crap, I don't have any way of handling negatives here. I need like an absolute value or something. If you're just trying to spot that with your eyeballs, it's going to be very mentally taxing eventually. Maybe you spotted this one right away, but eventually that's going to catch up to you. There's going to be something you'll miss. But when I'm running the debugger, it just jumps right out at me. I get to this line, and I'm probably going, well, this is going to be the next line. I hit step into, and I go right to here. And then I go, oh, crap, what happened? Well, negative a bunch isn't greater than 0. I'm not handling negative numbers properly. So let me add a math.abs here. Since I'm already storing the param in a separate variable, it gives me a good spot to do some input sanitation. I'm just going to take the absolute value right there. I should be handling negative numbers. So let's shut down the debugger. Let's run it so I can show just one more thing. the last button that I want to show before we run the test suite again. So I stop at this breakpoint. I'm not really interested in that one. Let's go to the other breakpoint. Okay, the input is big negative number. It changes to a big positive number. I can go through the loop, and it's going to work the same way as it did for the positive one. And say I'm running the debugger, and I'm somewhere in the middle of a method call, and I decide that I'm done with this method call, and I don't feel like clicking through it again. The last button I want to show is step out. What this is going to do is end the current stack frame. So even if this stack frame was going to call 20 other methods, create a bunch of stack frames, they all return, and then this one finally returns, whatever has to happen, step out runs until the current stack frame returns. So this will get us right back to the previous stack frame on the stack. We can see that that returned 45 eventually. We assert 45 equals 45, and we're feeling good about that bug. We've got rid of that bug, shut down the debugger, run our test without the debugger, and everything passes. So we're feeling good now. I'm ready to submit to Autolab and see if I get credit, or rather, ready to move on to the other two methods. For homework 4, you're going to do a lot of stubbing out methods. So another 2 examples of stubbed out methods. Average and best key. I'm not ready to implement. I'm just ready to test. Let's just return default values. But the one thing I want to show with those is for multiple best keys, when you have 2 keys that could both be the correct answer, a lot of you did if the return value is this or this, which is perfectly fine. You would do if, or assert true rather, computed dot equals B, or computed dot equals C. Case mattered for this one. Autocomplete got me. So this is what I would expect based on just everything you knew about programming at that point in time. But there is a different way. This can get tedious, by the way, if you have like 20 different return values that can all be correct. So what I like to do is create an array list with all the correct values. And then array list has a method called contains, which checks if this value is anywhere in the array list. So as long as whatever I computed is contained in my array list in at least one of those values, I'm going to call it good. That way I avoid these big Boolean expressions. This one obviously isn't too big, but they can get big. They will get big eventually. Okay, any questions on any of this homework-related examples before we get into linked lists again? Okay, let's get into the linked list again. So here's where we left off the linked list. Our linked list testing. We were testing the append method. We tested the size. We tested toString to make sure it returned what we wanted to. And by the way, I pushed this code to the repo for, I think it was in this section that was asked. I decided that why wouldn't I push this to the repo, so I pushed it in. And then we prepended to get the values that we expect while ignoring case. And then we wrote our method to check those 2 things while ignoring case. We iterated through, did equals ignore case for each one, and we're feeling good about that. So let's add to this. I want to test the find method now. So we have the find method, which is going to look for a specific value. It's going to check if that value is there or if we're at the end of the list. And if neither of those, we're going to make a recursive call to find. And find returns the node containing the correct value. Returning a node, say, let's set this up actually. Found equals actual dot find. And let's find green. Our find is not case insensitive, it's case sensitive, so I have to type it exactly as it appears in the other list. And then we would expect that to return this node, or rather this node, which is the same as returning this entire list. So we're effectively returning the list starting with the node that we find. So when we test this, we can use our compare list method again, and we have to ignore case again, of expected. Expected is this list. If we want to check if the list returned contains these values, expected.getNext. If we assert that that is the same as found, has the same values as found, then we found the right value, the right node with the value, everything worked the way we expect it. If these two lists are the same, well, ignoring case, or that they have the same values. And we pass. So we're feeling good. And I'm going to do what I said not to do on Wednesday. I'm going to copy and paste that test so we can test this again. I'm going to look for cyan. Let me make sure I have the right case. It's all lowercase. Cyan. And I'm going to change my variable to found2 so I can find the next value. Guys, come on. I'm going to change that. And now I expect this to be this list with just cyan. We have expected.getNext. If we call getNext 2 more times, we'll get to just this list. So let's call getNext a few more times. And this should be the list with just cyan. Or we could create a new list. We could just say new linked list node of cyan null. But I already have a list created, so I'm just going to reuse the list that we have right here. And I can run this. It's going to fail for a couple of reasons. Anyone tell me why, at least one reason why this is going to fail? One of the big things I said, why not to copy and paste tests like this on Wednesday. Easy mistake to make. It's probably pretty hard to spot. Yes, exactly. Nice turnaround, by the way. The second found needs to be found too. So when you're cut and pasting variables like that, you have to make sure you update the values in both places. If you're using it multiple times, you need to update it everywhere. So found to, I'm just updating my variable name, change it there. Very easy mistake to make, very easy one to not be able to see for a long time, especially if you're copying and pasting like 10 test cases. It's easy to make that mistake one time in the middle of all that. That's why I recommend doing something like we did Wednesday, set up your test cases in a more structured way where you're not renaming variables and you're not exposing yourself to that potential vulnerability. Now we're ready to run this test and we expect this one to pass, right? Do we? No. Don't. Oh, shit, it passed. Wait. I don't expect this one to pass, actually. What did I do here? Get next, get next, get next. Right? Let me change this to a new... Let me change this to a new linked list node. Oh, I know what I did. I fixed the code last lecture and I forgot to break it again. All right, well, here's the other way. At least we get 2 ways of seeing how this works. This one should fail now. And then we'll fix the code again. Okay, this failed. And we don't get much information here. The way we set up our test, we get assertion error, assert not null of actual failed. Not a lot of information to go by. We can set a breakpoint here and see, or actually, let's do that. Let's set a breakpoint right here. So we can at least see what was returned. We can get more information since our hint text, well, I didn't even have hint text on that assert not null, but it's just going to say, I expected null, but it wasn't. And then we can see what it was. But we can see found to is null when we expected it to just be a node with cyan. But it's null. Okay. Why is it null? Let's set our breakpoint up here. go into find. If you just click on this, by the way, it just reruns your thing, even if it's in the middle of debugging. So let's go into here and step through find and see what actually happened here. So we start with this. So this is a method in the linked list node class, the way we first did our methods. So we get this being a reference to the node that we're currently looking at. With the value red, we're looking for the value cyan. And we're not at the end of the list, so we're going to skip those and hit the recursive call. We're going to put another frame on the stack. This time, this is the node with green. And we can see the whole linked list. I think I showed this off before, right? We can see the whole linked list. We can see this is a node at 1070 with the value green, next of 1159, which is a node with blue, next of 1165, which is the value cyan, and next is null. So we can see the whole linked list. When we have all this collapsed, these are all the values on the stack in this stack frame. Whenever we expand one of these arrows, we're heading over to the heap and looking what's inside that object on the heap. So this is a reference to an object. We drop down. These are the instance variables of that object. This is another reference. These are its instance variables, etc. So let's run through again. We expect another recursive call. Blue is not what we're looking for. We get another recursive call. Cyan is what we're looking for. And we're going to check if this.next equals null, which it does. We're going to return null. And we never hit this check. We never checked the value of the last node. And we're going to return null. So our issue, and this is something I mentioned when we talked about find, we have to make sure we're checking the value at that last node first before we check for null. So we got to check the value of the last node and then null, or else we're not checking the value of that actual last node. So when we tested here, our find method worked great. Our find method worked great, and we're feeling good about it, but we needed to test that edge case. What happens when what we're trying to find is the last node of the linked list? We should have another test case of what happens if what we're trying to find is the first node of the linked list. Checking those edge cases is very important, and then our tests do pass. It's very important. It's a very common mistake. I see it in office hours all the time, where linked list code breaks, whether it's the first or last element, but works fine when the element's somewhere in the middle. So again, the debugger